Gamma rays are a form of high-energy electromagnetic radiation that have the shortest wavelengths and highest frequencies in the electromagnetic spectrum. They are produced by various nuclear and subatomic processes, such as nuclear decay, nuclear reactions, and particle interactions. Here are some key points about gamma rays. Origin. Gamma rays are typically emitted during nuclear reactions and radioactive decay. They can be produced by processes such as nuclear fusion, nuclear fission, and the annihilation of matter and antimatter. Properties. Gamma rays have extremely high energy and penetrate matter very easily. They have no electric charge and no mass, allowing them to travel at the speed of light. Due to their high energy, gamma rays have the ability to ionize atoms and molecules, causing damage to living cells and materials. Sources. Gamma rays are emitted by various sources in the universe, including supernovae, pulsars, quasars, and black holes. They are also produced in nuclear reactors, particle accelerators, and in certain medical and industrial processes. Applications. Gamma rays have numerous applications in various fields. In medicine, they are used for cancer treatment, radiotherapy, and diagnostic imaging, gamma ray imaging. In industry, gamma rays are employed for sterilization, materials testing, and quality control. Gamma ray spectroscopy is used in research to study the composition and structure of atoms and molecules. Detection and protection. Specialized instruments such as gamma ray detectors are used to detect and measure gamma rays. Due to their high energy and penetrating nature, gamma rays can be hazardous to living organisms. Proper shielding and safety measures are necessary when working with or around gamma ray sources to minimize exposure. It's important to note that while gamma rays have various practical applications, they can also pose health risks. Excessive exposure to gamma radiation can damage living tissue and increase the risk of cancer and other radiation-related illnesses. Therefore, it's crucial to handle gamma ray sources with caution and follow appropriate safety protocols.